Alright, so we have an example of a fraction where the denominators are actually linear factors. So let's go ahead and express this as a partial fraction. The first thing I'm going to do is to rewrite this fraction again. So 11x plus 12 divided by 2x plus 3 into x plus 2 into x minus 3. Now, since these are three linear factors in the denominator, this fraction has to correspond to three partial fractions. Now let's assume these partial fractions are capital A divided by 2x plus 3. I'm going to have to find what that capital A is, plus another constant B divided by x plus 2. I have to find what that is, plus C divided by x minus 3. So if I find A, B, and C, then I will already know what the partial fractions of this are. Let's go ahead and write this 11x plus 12. Oops, just write this well. 11x plus 12 divided by 2x plus 3. Is that good enough? 2x plus 3 into x plus 2, x minus 3. So let's try to create a common denominator, the LCM of all these three partial fractions. 2x plus 3 into x plus 2 into x minus 3. So this becomes A into x plus 2 into x minus 3 plus B into 2x plus 3 x minus 3. Okay, almost there, plus C into 2x plus 3 x plus 2. Alright, there we go. So you can see that the denominators are the same, so this denominator and this denominator can cancel out, and now I have only the numerators. Okay, let's go ahead and do that. So I have 11x plus 12 equivalent to A into x plus 2 x minus 3 plus B into 2x plus 3 x minus 3 plus C into 2x plus 3 x plus 2. So I have to choose specific values of x that are going to help me find some of these constants. For example, if I put x equals negative 2, let's begin with x equals 3. So if I put x equals 3, I know that all this is going to be 0, all this is going to be 0, because 3 minus 3 is 0, even here 3 minus 3 is 0. So in that case, I'll have 11 times 3, just write this, 11 times 3 plus 12 equals, this time around not equivalent but equals, because I've chosen a value of x. So I'll have 0 plus 0 plus, let's put C into 2 times 3 plus 3 into 3 plus 2. So we have 45 here, that's 33 plus 12. This side we have, okay, that's C into, that's 6 plus 3, that's 9 times 5. So we have 45 equals 45C. If I divide both sides by 45, cancel this out, this is 1, 1, so C equals a 1. Alright, so let's go ahead and find the other constants by choosing another value of x. So what should we choose now? So let's put x equals negative 2 here. If I put x equals negative 2, still negative 2 will make this to be 0 and this to be 0. So let's see what we have here. I'll have negative 22, because that's 11 times 2, negative 2, okay, plus 12 equals, on the other side we have 0 plus, so if I put negative 2 here and negative 2, just take off this, if I put negative 2 here and negative 2 here, I'll actually have 5b. You can do the math there. This becomes 0, so I have negative 10 equals 5b, and then I'll have b equals -2. Okay, so I have b and c. I have to find a. Let's go ahead and do that. So let's put x equals, I can just choose any value of x because I already have the first two values of b and c, but I can go ahead and choose a value that will make some of the coefficients 0. So let me choose x equals -3/2. Alright, so if I choose x equals -3/2, let's see what we have. I'll have -11 out of, was that -11? I guess that's -33 out of 2 plus 12 equals, on the other side I have -9 out of 4 times a. You can do the math there, that's what we get, plus 0 plus 0. So have -9 out of 2 equals -9 out of 4a. So if you, these negatives can cancel, the 9s can cancel, so you'll just get a equals a +2, and there we go. So I have all the three values, a, b, and c. So let's write the final answer now. So finally I can say, just get this blue color, finally I can say 11x plus 12 divided by 2x plus 3 into x plus 2 into x minus 3 is actually the same as a, which is 2 divided by 2x plus 3 plus b. Right, so b is actually -2, so we just say -2 over x plus 2, then plus c, which is c is a 1, so that's 1 over x plus 3. Okay, so this is how we can express this as a partial fraction. Thanks for watching this video. Don't forget to click that subscribe button for more interesting videos, and I'll see you in the next example.